All right. Good afternoon, everyone. I hope you had a good midterm exam, and I think everything was pretty straightforward in the midterm exam. I asked you to just determine the objective variable and put them in a box and then get the result. All other formulas were available in the Excel sheet. So your job was to just identify the decision variable and also calculate the objective variable. And in future exams or quizzes, if you have any questions, you can join my virtual room. I will help you to answer those questions. So, do you have any questions, ideas about midterm exam? Okay. And today we are going to work on another variation of the logistic model. You know that in logistic, the objective is to send goods from some certain nodes from the other nodes and with the minimum cost. And we also want to meet some constraints. So in logistic model, we have a kind of graph. The simplest form, we have two types of nodes. But in today's example, we are going to add another level of nodes. Okay. Last week, we worked on the simplest form of kind of logistic. We had one level of input nodes or origin nodes. We have one level of nodes for destination. Destination is where those goods end up. And for today's example, we are going to add another level, intermediate node, which is also called transshipment. Transshipment or intermediate node. Okay. In logistic models, we may have one form of transmission, one form of product, one or multiple form of product, transportation, and time frame. We may have different form of product, transmission, and time frame. Last week we worked on just one type of product in one form of transmission, and we didn't have any constraints regarding the time frame. Okay, today we are going to work on a kind of more complicated form of the logistic model. In this kind of model, in today's example, source nodes can send and receive information from each other, to or from each other. These are the source nodes, and these products must be shipped to the destination at minimum cost, and some constraints must be met. Here, for the source node, as you know, we have some certain capacity. It's supply, limited number of products, and at the destination, we have demands. Like car manufacturing plants and dealerships. They demand certain number of cars, and the source must provide that number. Today we are going to send this goods from the intermediate nodes. All these goods must go through these intermediate nodes. These are like inventories, warehouse, or whatever. So all this, the number of products shipped must not be bigger than the capacity. This is one constraint. The numbers delivered at the destination must at least meet the demand of the destination or customer. And the transshipment, it must be the difference between inbound and outbound must be 0. It's just an intermediate node. So for this type of problem, we need to calculate the inbound or inflow, and in this example it is called inflow. Number of items transmitted to this node, and we have outflow, number of items sent out of that node or that plant. For the origin node, the outflow minus inflow must not be bigger than the capacity. So outflow minus inflow must be less than the capacity. And for the destination, it's the opposite. We have inflow and we have outflow. Inflow, total number of items delivered at the destination minus total number of items sent out of that node must be bigger than or equal to the demand. These are the two constraints for this model. Because these nodes are receivers, these are senders, and these are just intermediate nodes. Difference between inflow and outflow for these intermediate nodes must be 0, because they do not keep inventories. Now please take a look at this example to see what you should do for this example. Okay, please pay attention here. As I said, you have 3 types of nodes. For the source nodes or plants, origin or whatever, the total outflow, the total number of items sent out must be less than the capacity of the plant. For the intermediate node or warehouses, these are temporary location, temporary storage. And outflow, the total outflow must be 0 or net outflow. And for the destination, some items must be delivered. So total net inflow minus outflow must meet the demand of the destination. And these are the links, the path between the source or plant warehouses and between warehouses and the customer. And each link has a kind of certain maximum or capacity. For example, one trailer cannot carry more than 20 tons. These are the capacity of this one. So we want to determine how we can meet the demands of the customer and also keep the transportation costs at minimum. So the objective is to minimize the shipping cost. First, I'm going to define name for these nodes, the origin or source nodes. First, you need to highlight these nodes and then go to formula, create from selection. Top row is going to be the name of this variable. The same for destination. Create from selection. Unit cost. Flow, or the number of items shipped, is going to be our decision variable. I'm going to color it pink, or this is kind of orange. Okay. Data, formula, I have to define flow as our decision variable. Select, create from selection. Okay. We have other variables like arc capacity, or the maximum capacity of a link. Plant net outflow is the next variable. Plant capacity. Warehouse net outflow. Required. Customer net inflow, or the destination node, and customer demand. Now I'm going to define the constraints. The flow of each link must be less than the capacity of maximum capacity of each link. So flow, or the number of items shipped, must be less than or equal to the arc capacity. Planned net outflow must be less than or equal to planned capacity. For warehouse, it must equal to 0. The net outflow of each plan must be 0. And for customer net inflow, must meet the demand of the customer, so it must be at least equal to the customer demand. Okay. So these are the main constraints. Now I'm going to connect these variables to the decision variable. The common arc capacity, arc refers to the capacity of each link, or the tonnage of a kind of trailer or whatever. This one equals B4. The maximum number of items can be sent through a pass is 200, and it is the same for all those links. Now we have to calculate the plant net outflow. It equals sum if the total number of items outflow, origin, node 1 or H9, and flow. This formula calculates those items that shipped from node H9 or node 1 minus those items shipped to node H9. Sum if destination, those numbers, those items whose destination is H9, and flow, which is the number of items. This formula calculates the numbers sent, the net outflow of node H9, and we can copy to the other cell. We have 3 origins or source, 1, 2, 3. We can copy this formula for the warehouses. Their net outflow must equal 0. For the destination nodes, or these two, 6 and 7, this formula is the opposite. maximum number of items sent or delivered at node 6 or H20 minus those numbers sent out of this node. Sum if this origin is H20 or node 6. And flow. We copy this one for node 7. Now we have connected all these nodes to the decision variable. We can go to formula, to data, and then select solver. I forgot to define total cost as our objective variable. Formula, create from selection. Does that make sense? If you have any questions, let me know. Which part of that is kind of confusing? Okay. Now we can go from this menu, you can get the list of defined variables. We have defined our capacity, customer demand, customer net inflow, and etc. Now we can go to data tab and solver. For the objective, we have to define total cost as our objective variable. Our decision variable is going to be flow. We want to minimize the total cost. And now we have to add the constraints. First constraint is that flow must be less than the arc capacity, less than or equal to the arc capacity. The second constraint is that planned net outflow must be less than the planned capacity. Planned underline net underline outflow must be less than or equal to the planned capacity. Add. The third constraint is that warehouse net outflow must equal 0. Warehouse underline net underline outflow must be equal to the required. And the last constraint is that customer net inflow must be bigger than or equal to the customer demand. Net inflow must be bigger than or equal to the customer demand. So we have defined all our variables, but I forgot to define formula for this one. Total cost is going to be sum product of unit cost and flow. Unit cost and flow. We want to minimize this total cost. Total cost, we want to minimize it. Decision variable is the flow and these 4 constraints. From this drop-down menu, we need to select simplex linear programming and then click solve. With this number of items, shipments, we can minimize the total cost to $3,000. That's how we can solve this kind of logistic problems. Does that make sense? Okay. Yeah, that's how we solve this kind of problem, logistic model. I will upload this solution in Box. And here in this sensitivity report, you can get the report for the shadow price, how much extra the company must pay for the variation of the cost and other variables. And these are the optimal values for the flow. Is there any questions? All right. Thank you very much. That's all for today.